Okay, in this final video for this section, we are going to learn how to find the absolute minimum and maximum values for a continuous function over a closed interval. And I've actually already explained this, so now let's kind of formalize it here. We can call this like absolute min and maximum of a continuous function on a closed interval. So if f of x is continuous on AB, and so AB is a closed interval, so if f of x is continuous on a closed interval, then the absolute min and max of f of x on AB are going to occur either at the critical points of f of x or at the endpoints of the interval. Okay, so they'll either occur at the critical points or the end points. So all we need to do is find the critical points and then just evaluate the function at each of the critical points and the two endpoints, and of those values, whichever one is the smallest will be the minimum value over the whole interval, whichever one is the largest will be the maximum value over the whole interval. And so let's go ahead and give this a try. We're going to do find the absolute min and max of this over the closed interval 0 to 2. And so what I'm going to do is I'm going to find the critical points. Okay, I'm going to find when the derivative is equal to 0. So first I need to take the derivative, so I get 2x minus, if I bring down the 1/2, I get 3/2 x to the negative 1/2. Okay, and so now I set this equal to 0, so I could rewrite this as 3 over 2 to the square root of x, and this is equal to 0. So already we can see we have a critical point. We have a critical point when x is equal to 0. Why is that? And not because the derivative is equal to 0, but the derivative is undefined at that point. Okay, now that also happens to be the endpoint of the interval. Okay, so but that would be considered a critical point of the interval, okay, where it's undefined. So now I'm going to solve this equation and see if there's any more critical points. So I got like 2x is equal to 3 over 2 square root of x. And then I could think of this like as cross multiplying, so that I get 4, and this would be x times x to the 1/2 would be x to the 3/2. And then this would be 3 times 1. So I would get this here, and then I would get x to the 3/2 is equal to 3/4. Okay, and then to solve for x, I'm going to multiply. I'm going to raise both sides to the 2/3 power. Okay, because that's the reciprocal of this exponent. That's going to make just this x here, and then I get like, like the cubed root of 3/4 squared or whatever. So, or just 3/4 to the 2/3. So let's find out what that is. So 3 divided by 4, and I'm going to raise that to the 2/3 power, and I get like approximately 0.825. Okay, so that would be like another critical point, approximately 0.825. Okay, so now to find where the maximum value occurs, I'm going to find, and I got to remember to use this and not the derivative, but I'm going to evaluate it at 0. I'm going to evaluate it at this 0.825, and I'm going to evaluate it at this other endpoint. Okay, so at the two endpoints and at the critical points, it's just that in this case, one of the endpoints happened to be a critical point. So if I plug in 0, I clearly get 0 here. So if I plug in 0.825, let's see what I get. So this would be like 0.825 squared minus 3 times the square root of 0.825. And this is like a negative 2.044, so negative 2.044. And then now I can evaluate it at 2. Oops. So now I would get 2 squared minus 3 times the square root of 2. And there I get a negative, approximately negative 0.246. And so if you look at this, it looks like the max occurs at x equals 0, and it is 0. And the min is going to occur at x is approximately like 0.825, and it's negative 2.044. Okay? Those are going to be the global min and global max, and then that endpoint is neither. So let's actually graph this and see how it looks here. So I'm going to do x squared minus 3 times the square root of x. And then maybe I'll graph this window. We'll do, I can do maybe negative 1 to 3, because my interval is 0 to 2. So negative 1 to 3, and then maybe, I don't know, negative 4 to 4 is probably plenty. So we see it looks kind of like this, and if we plug in 2 here, if I plug in 2, I can see, I plugged in 1, so let me do that again. If I plug in 2, then I see that this is the one endpoint. So indeed, the 0 is the max, and let's see if what we got here is the min, 0.825. And yeah, it's believable. It's down here, and then it kind of starts going back up. So that's actually where the critical point is in this case. Okay, and I'm not sure what it did there. Oh, I must be doing a guess. I'm not sure. So quit graph. Okay, so yeah, so there you go. We found the min and the max for that example. Okay, well, let's try another one here. It says find the absolute min and max of this function, cosine of 2x plus 2 sine of x, on negative pi to pi. Okay, so I'm gonna find the derivative here. I'm gonna find the critical points, and this is a continuous function on the closed interval. You want to check that first. And now I'm gonna take the derivative here, so f prime of x. This would be the opposite of the sine of 2x times 2, plus this would be 2 cosine x. Okay, and so now maybe I can simplify a little bit here and then set the derivative equal to 0. First of all, this will never be undefined, and so let me do 2 cosine x, and then this is minus, and the 2 would go out front, and then sine of 2x, and that's equal to 0. So I'm just commuting those around. And now I need to solve this equation. So what I can do is I can do the double angle identity. 2 sine x cosine x. So it would look like that. And so this would be 2 cosine x minus, and so using the double angle identity, this 2 multiplied by that 2 would be 4 sine x cosine x is equal to 0. And then I can pull, I'm going to factor this. So to solve a trig equation, we factor. So I'm going to pull out a 2 cosine x, and then I'll be left with just a 1 minus 2 sine x, and this is equal to 0. And so now I set each factor equal to 0. That's how we solve trig equations. This thing solves into the sine of x is equal to 1/2. That's moving the sine x to one side and dividing both sides by 2. And so, so we gotta remember here that this thing is between negative. It's going to be on the unit circle. This is like -1. This is 1. But we're going from negative pi, so I'm starting here, negative pi going to positive pi, I think. So it would be so it's going around the circle, but it's going from negative pi to positive pi. So when is cosine x going to be 0 in this interval? Well, the cosine x is going to be 0 at negative pi over 2, and it'll be 0 at pi over 2. Okay, and then when is sine equal to 1/2? Well, it'll be 5 pi over 6, and I'm sorry, pi over 6 and 5 pi over 6. That's when the sine is equal to 1, the y value is equal to 1/2. So pi over 6, 5 pi over 6. Okay, and so now we found the critical points. These are the endpoints of the interval, and now we got to test them all. There's 4 points. So let's write them down. So we got f of negative pi, f of negative pi over 2, f of pi over 6, f of 5 pi over 6, let's see. Oh, nope, I'm sorry. We should do f of just pi over 2. Pi over 2. And then, let me actually erase f of pi over 2. And then f of 5 pi over 6. And then f of pi. Okay, and so, I don't know, maybe we can do these fairly easy. So if I put in a negative pi here, I get negative 2 pi, and that would make this equal to 1. So I'd get 1 plus, and then at negative pi, the sign would equal 0, so 2 times 0. So that would just equal 1. If I plug in negative pi over 2, then this would be just negative pi. The cosine of that would be negative 1 plus, and then if I put in negative pi over 2 here, this would be 2 times negative pi over 2. For this would be the sign is 1, or negative 1 here, so that would be a negative 1. And so this would be negative 3. If I put in 5 pi over 6, that would make this pi over 3. And pi over 3 cosine for pi over 3 would be 1/2. And then I would add 2, and then if I put in pi over 6 here, I would get sine that would be 1/2 as well. So this would be 1.5 is what that would be, 1.5. Okay, if I put in pi over 2 and I place that into here, pi over 2, I would get pi, cosine of pi is -1 plus, and then if I put pi over 2 here, I would get 1, so that would be 2 times 1. And so that would be what, no, that would be just 1. And then if I put in 5 pi over 6, this would make this -1/2 plus, and then 5 pi over 6 here, that would be +1/2, so 2 1/2. And so this would be 1 plus -1/2. That would be 1/2. And then pi, if I plug in pi here, I'd get 2 pi. That'd make that 1. And this is assuming I did all these right. We'll look in a minute. And then if I plug in pi here, I would get 0. And so I'd just get another 1 here. Okay, and so what this would mean would be negative pi over 2 is my minimum value, and my maximum value looks like it's going to be the pi over 6. Is that right? Let's check it out. Okay. And we'll see if I did it right. All my math right. Okay, so now this is, we're going to do, cosine of 2x. So cosine of 2x minus 2 sine of x. And then I'm going to do, maybe I'll change my window, and I'll do from negative pi to pi, that's my interval, and then we'll do -4 to 4. Okay, now this isn't right here. I think I added and didn't subtract. So let me go back. All right, subtracted. This should have been added. So there we go. That'll make a difference. That looks a little more familiar. Yeah. So let's check this out. Okay, so this is what I get. So let's try some of these. So when I put in negative pi and pi, let's do my value. So if I put in a negative pi, there's the 1, and I think I'll get the same thing if I put in pi. Yes, I get 1 each case. So this was negative pi over 2. That's where the minimum value occurred. So negative pi over 2. Yep, that is the minimum value, right? And then pi over 6 we said was the maximum value. And over this interval, I think it's going to be right there. So pi over pi over 6. And that is 1.5. That's maximum because these are 1. Now the thing is, 5 pi over 6 should have gave me another maximum value. So let me look and see why I didn't get. That was confusing to me. Okay, so for 5 pi over 6. So if I put in 5 pi over 6 here, I see why. I would have gotten 5 pi over 3, so this would have been cosine of 5 pi over 3, which would have been down here, which would have been positive 1/2. And so this should, and that's what I was wondering about, because I remember there being 2 global maximums, and those are the 2 global maximums right here and here. So, and this was another relative, and that was at pi over 2. Yep, that was another relative min, which was also 1, right? So that was the same as the 2 endpoints. So this was the max, and this was also a max, and this was the global min. Okay, so that's the idea here. So let me do one more, and I'm going to purposely make a mistake here, and then we'll correct it, just to show you kind of what can happen. So again, we have a continuous function over a closed interval, so I'm going to take the derivative. And if I do that, I get 1 minus, bring the 2/3 down, I get 2x, subtract 1 from the exponent, I get negative 1/3. Okay, and so now I'm going to set the derivative equal to 0. Find out when it's equal to 0. And so when I do that, I can bring that over to the other side. I'd have like 2x to the negative 1/3 is equal to 1. Divide both sides by 2. This would be equal to 1/2. That's 1/3. And now, to get rid of that, I'm going to raise both sides to the negative 3. So that makes this equal to just 1, x to the 1. And then this will be just 8, is what that'll be. Okay? And so this looks like my only critical point here. And so now I'm going to test this at the negative 1/2, at 8, and at 10. And so let's see what we get when we do that. So for negative 1/2, so negative 1/2 minus 3 times negative 1/2. Negative 1/2 to the 2/3. And I get like approximately negative 2.3899 or so, rounded to 4 decimal places. Okay, well let's try 8. Let's raise it, or let's put in 8 here. So 8 minus 3 times 8 to the 2/3. And I get negative 4. And then let's try 10. So 10 minus 3 times 10 to the 2/3. And I get negative 3.92. 5 or so when I round to 3 decimal places. So this is what I get for each one of these. And so what that means is this would be like the relative max, or the absolute max over the interval, and this would be the min over the interval, because this is the smallest and that is the largest, even though it's negative. So that would be the max and that would be the min. Now let's graph it and see if we're correct about that. So the max occurs at negative 1/2, the min occurs at 8. And that's the left endpoint of the interval. Okay, well, let's graph this function. So I got x minus 3 times x to the 2/3. And then let me do a window here. I'll do negative 1/2 to 10. And then these are all negative, so maybe I'll do like negative 5 to 5. Okay, so let's actually plug in. Oh, I did negative 5 to 5, but this thing needs to go to 10, doesn't it? So let me change my window. Oh, I did 0.5 to 10. Okay, I did. Okay, well, let's see. So that where I said the max occurred was at that endpoint, and it doesn't seem like it is the max, does it? So the value at negative 1/2 is right there, the negative 2.38, but that certainly is not a max, right? It's going way up to there. And so the problem is I missed a critical point, and the critical point is when the derivative is equal to 0. If you notice, it's in this case, the critical point is not when the derivative is equal to 0, but it is it's when the derivative is undefined. So let me zoom in on it. You can see that it kind of goes up and makes a sharp turn. And so at 0, that's the maximum value. So you could plug in 0, and you get 0 for a maximum value. And we'll look at more of that in a second, but let me show you the 8 is the minimum value. So if I plug in 8, I actually get this value right here, which is negative 4, like we saw. Okay, but now if I plug in 10, it actually goes back up, and it's like at negative 3.92. So even though it's hard to see exactly when it starts going back up, it does, if I do 7, it's there at like negative 3.97. If I go to 9, so 7, you get like negative 3.97. At 9, I get like I get negative 3.98, right? But then if you go to 8, right there between the two, you get negative 4. And since 8 is a critical point, that is that relative minimum value, and in this case it is the minimum value over the whole function here. Okay, if you do the negative 1/2, because you actually would get something like this. It's actually going, this is negative 1/2, and it's actually going up and then way down, and so this actually is 8, negative 4, the minimum value over the whole thing. This is the maximum value, and the reason we missed it, like I said, I was going to make a mistake on purpose. The reason we missed it is when we take the derivative here, this is a negative exponent, so the derivative is actually like this, 2 to the cubed root of x, and then I can see that f prime of 0 is undefined, and since f prime of 0 is undefined, that is a critical point, and you don't want to leave it out. If you leave it out, then using this method you could not get the correct min and max. You gotta include all the critical points, not just when the derivative is equal to 0, but also when the derivative is undefined. So, okay. So, yep, we'll finish there.